Hey guys, Buildzoid here, and today we're going to be taking a look at I guess you could consider it an in-progress repair of this here HD7970. So this is a HIS X-Turbo HD7970. It's a rather rare 7970 PCB, and it's pretty comparable to, say, like an HD7970 Lightning. The VRM on this is really, really nice. This is all V-Core. So we've got one hell of a V-Core VRM, two-phase memory power, two-phase VDDCI. And I got this card as 4 parts not working on eBay for, I think, 50 quid, which is a bit much to pay for a dead 7970, but honestly, I couldn't believe that, I could get this PCB. Like, regardless of what condition it was in, I wanted this PCB. There is very little on the internet. Well, I don't think there's any good pictures of this PCB on the internet. Well, actually, there are now, because I've taken a few and already uploaded them some places, but, yeah, so I really wanted one of these just for the PCB. Like, even if it was a complete, even if there was an internal short circuit in the PCB itself, I wanted one. So 50 quid, too much for a dead, I'd say too much, yeah, definitely too much for a dead 7970, but to me, this isn't just a 7970. This is a very specific 7970. Anyway, so the card showed up with a 0.15 ohm short circuit on the memory power rail. So initially I was kind of hopeful that this would be, very repairable, because if you have a short circuit on a power rail that's like that low, I was like, oh, maybe one of the low side MOSFETs failed, so I'll just have to replace a MOSFET and I'll have a working HD7970X Turbo, which would be, best case scenario. What actually turned out what actually ended up happening is, I desoldered the inductors partially just to lift them up so I could isolate the low side MOSFETs from the output of the VRM. That way you can check if the low side MOSFETs are actually shorted, and they weren't shorted. So that was a problem. Yeah, the low side MOSFETs on this card are in perfectly good condition. And so, yeah, that's not great. So then I tried injecting voltage into the board to, try, which I did from these capacitor pads over here, to try find what part of the card is getting, very, very hot. Because that's one way to, that's one of the best ways to try hunt down short circuits. And that didn't really go anywhere because all of the memory chips were just lighting right up. And they were pulling a lot of power. Like, the 18 gauge cable that I was using to connect my power source to the card. And I'm not a power supply, by the way. It's a RX 480 VRM that I use for this kind of thing, because that RX 480 VRM will quite happily supply even 100 amps. So there is no short circuit it'll just burn through a lot of things if the short circuit is bad enough. So I do have to be careful with it, but on the flip side, I don't have to worry about never having a power short, not having enough power to get something to heat up. Anyway, yeah, so it was pulling so much current that the RX 480 VRM, which is set to 1 volt, was, well, by the time that voltage, by the time the power got to the card, it was at 0.85 volts. And basically, if you measured the voltage over on this side of the card, it was significantly lower than if you measured it over here. But the hottest memory chips were in this area, and so I sort of went okay, I guess we have some shorted out memory chips, though all of them were getting really hot, considering how little voltage I was shoving into them. So I started desoldering memory chips. I desoldered a memory chip. I check if the short circuit is still there, and surprise, surprise, the short circuit was still there. And so through that process, I eventually ended up with a card with no memory chips. And the short circuit was still there. However, it was no longer 0.15 ohms. It was now 1 ohm, which is quite a bit higher, but that doesn't really help me because it's where is this short circuit? So after some more hunting and searching, and also also complaining about how difficult this card is to repair on Discord, somebody pointed out, well, basically I noticed that I have a voltage leak into the 3.3 volt power, into the 3.3 volt rail on the card. So basically, if I was injecting 1 volt into and man, there's flux in that area, and I just touched that. That is awful. Anyway, Yeah, so if I was injecting 1 volt into the card, I'd be getting like 0.25 volts on the 3.3 volt rail, which is just like, where the hell is that coming from? Now, I first noticed it in this area of the PCB, and I didn't realize that it was leaking into 3.3 volts, so I thought, oh, maybe this chip's like dead. So I desoldered that chip. The voltage leak was still there. I was still getting 0.25 volts on the 3.3 volt rail, and then, complaining on Discord, somebody pointed out, like, you should just try, like, all the control, like, check the controller, right? Like, what if the controller is connected pretty much directly to the output of the memory VRM? If that thing is, like, shorted out internally, it could realistically, because the voltage controller runs off of 3.3 volts on these cards, so, if that thing was shorted out just right, it could realistically leak whatever is being applied to the memory rail to 3.3 volts. And so I desoldered the CHL8228G, and now with no memory chips, no CHL8228G, and the memory VRM actually, well, partial, like the memory phases are restored. There is no more short circuit. So we're just going to measure that across this capacitor right here. And we get 67 ohms, which is the resistance of just the memory controller of the GPU core on this card. So that is a nice, healthy resistance. A healthy 7970 with all of its memory chips still in place should be, if off the top of my head, should be like north of 30 ohms of resistance, or north of 20. I'm not entirely sure. Like, the thing is, depending on what memory chips you have, the resistance can be different. Like, Samsung memory chips tend to have very low resistance. Hynix, though I don't think there's ever been a 7970 with Samsung memory, but like Hynix memory chips tend to have relatively low resistance. Elpida, I don't know. But, you're talking about tens of ohms, not what this card came with, which was 0.1 ohms, and after I desoldered all the memory chip, it was still, all the memory chips, it was still 1 ohm. So now that, it doesn't have the shorted voltage controller, and what I suspect was all of the memory chips being shorted, yeah, we don't have a short circuit on the memory power rail. However, there is still the possibility that the actual memory controller in the GPU core is dead. But I won't know if that's the case until I like reinstall all the memory chips and see if the card boots, and also have to reinstall this chip over here, but that's no problem. And you might be wondering, why haven't I already reinstalled the memory chips? Well, I can't do BGA. Like, I can't do BGA right now yet. So, yeah, I've kind of been putting off learning how to do that, and well, now I have like the thing. Yeah, so I just need to learn how to do that. Which it hasn't been a high priority, but I think for this card, I do definitely want to do that. So, yeah, basically repopulate all the memory chips, and if I'm lucky, the memory controller survived and the card will fire right up. If I'm unlucky, the memory controller's toast and we need a new chip. Like, new main chip, in which case I think I might just find somebody who does, like, full-blown BGA swaps and send them a 7990 and this card to get the core swapped around, because, yeah, I really want one of these in working condition. Like, this is quite a rare card, a very unique card, a card a lot of people don't know about, because everybody knows of the 7970 Lightning and the 7970 Matrix, but the X Turbo, like, this is basically the same VRM that you get on the Lightning. So, like, yeah, I'm a big fan of this PCB, and so I'd love to have it in working condition. Anyway, what we're gonna do for the rest of the video is actually check if all of these memory chips are actually shorted out. I'm pretty sure they are, because I've checked a few of them at random, and they tend to be like 1 ohm of resistance, which, if you had all of them in parallel on the GPU, along with the 1 ohm resistance of the voltage controller, that would explain why the, overall memory power rail with all of its memory chips and the shorted out controller was measuring as 0.15 ohms, because that also includes some contact resistance from the multimeter. So, well, I mean, from the probes. So realistically, like, yeah, there was like a really low short circuit, but that short circuit was actually distributed across all of the, I think it was distributed across all of the memory chips and the voltage controller. So we're going to check if every single, like, if every single one of these memory chips is actually dead, I'll feel less stupid for removing all of them. I've checked 2 already, and they were dead. So, yeah, I've also mixed these up, and so I don't know which ones the dead ones are, but yeah, so we're just going to go through and actually check all the memory chips. And actually, I do still need the card here. So let's take a look at the pinout for these memory chips, which I did manage to find. Yeah, so these are the memory chips that my card comes with, and we have this lovely pinout for them. So VSSQ is ground, VDDQ is memory power. And it's a bit confusing because so like VDDQ and VDD on the GPU PCB are actually the same thing. On the memory chip, they're internally separate. And so if we scroll down a bit, you see that right here where we have like IO power supply isolated on die for improved noise immunity. IO ground isolated on die for improved noise immunity. So this kind of looks like it might be a separate power rail, but it's actually not. Like on the PCB of the GPU, VDDQ and VDD are the same thing. It's just internally inside the memory chip, they're different. And then the same goes for VSS and VSSQ. And we can prove that because if I scroll up here, right? So I actually scroll up a bit more. I'm pretty sure these pinouts are both the same, but anyway, that doesn't really matter. So if we go VSSQ and VDDQ, right? And you'll notice that VSSQ and VDDQ are in every single corner, right, of the memory chip. So literally any corner, like if you just measure these two solder balls, like, yeah, these two pins next to each other, you're always going to be measuring like ground versus memory power. So if we look at the actual card, I'm going to take that measurement right now. So we're going to take one probe on ground, right? So that's going to be our VSSQ. And we're just going to go to right. I'm going to have to stop talking and there. Yeah, so that's ground. That's just straight up ground. That's the same as ground anywhere else on the card. Like if we take, I don't know, ground off of this capacitor over here. Same thing. I mean, you know, different resistance because obviously making contact with a solder ball that's a bit covered in flux is a bit more difficult than with a capacitor over here. But yeah, and then if we go to the other solder ball, which will be super awkward, we can see that that's the memory power rail resistance, right? Like if I measure to the memory power rail now, we get the exact same thing because it is the same thing, right? Like that. So VDDQ is memory power, VSSQ is ground, and VDD is also memory power, but I'm not gonna try to count which solder ball that is. And VSS is also ground. So on the card itself, you don't actually have two separate like VDD and VDDQ rails. That's internal to the actual memory chip. Because yeah, memory is like weird like that. So, and that's actually standard practice for a lot of different memory standards to isolate the power supply inside the memory chip itself, not on the actual not on the actual like device that's powering the memory. Anyway, so we're just gonna go chip by chip, checking two of the solder balls and seeing if they're completely shorted out. So I'm just gonna move this so that we can zoom in a bit so you can see that I'm not screwing up the measurements. And there we go. Got our memory chips. Oh, the multimeter. And actually, let's organize it like that. And one more reminder of what we're measuring. So, oops. There we go. So VSSQ. So first solder ball in any corner, right? This is important that it's every corner is the same. So every corner is ground, memory voltage, ground. So we can check like, you know, we can do like a sanity check of like ground versus ground resistance and then do ground versus memory power. And then if like, so these two should be like 0 ohms for all, like 0.06 or something, like really low, like it'll be the resistance of the contact resistance of the probes that I'm using. Whereas, well, depending on how badly shorted out the memory power rail is internally, this should be higher than the like ground to ground resistance. Ground to memory power, you would like, even if it's shorted out, I don't think it's going to be 0. And anyway, so let's go back to those memory chips and start probing them. This is going to be super awkward for me. So, yeah, this is going to suck. So that's ground to ground right now, or at least it should. Okay, I'm gonna have to get something so that I can like hold the memory chip down with my finger. Just take this bit of paper. Because the memory chip keeps moving otherwise. And then we go... And I don't want to touch the memory chip with my finger because that'll obviously... Well, I mean, it'll throw off the resistance, but just a little bit. So that's ground to ground, and that gives us a measurement that makes sense, right? Like ground to ground, we get a very low resistance. And then ground to second solder ball, we get 0.7 ohms, which is... That's still a short circuit. Like, that's not a working memory chip, so that one's toast. Next chip. Let's see, are you toast? Actually, I'm just going to skip straight to the second solder ball. Oh, wait, you guys can't see anything again. I'm going to get that second one. And 0.8 ohms, so also dead. Like, if I was actually touching the probes together, we would be getting 0. Like, you know, zero, very low resistance. And if I was touching ground and ground, we'd also be getting very low resistance, as demonstrated by that very first chip. Get that. No. 0.7 again. I mean, if I check the third solder ball, what's that like? Man, that is really hard to... I think that's the second one, isn't it? That's the second one. So this is the third. Yeah, so yeah, you can see the third one's basically contact resistance. Right, so that one's toast. I think all of them were getting insanely hot with just like 0.8 volts being applied to them, so I think every single one of them's dead. So at least I don't feel like a complete moron for desoldering all of them. 0.8, dead. Come on, are you dead? Man, I'm really worried. Like, I'm hoping that if all the memory chips, like, I'm really hoping that the memory chips shorting out, like, sank all the energy that would have otherwise harmed the memory controller. But at the same time, those memory chips go all the way around the GPU core. So somehow I have the sneaking suspicion that, like, unless the memory controller has a significantly higher voltage tolerance, right? Like, the memory controller can survive, I don't know, 2.5 volts for, like, a short burst. And the memory chips can only survive, like, 2 volts. So if you apply, which 2 volts is really low for memory chips. Memory chips tend to be surprisingly tough. Well, let's say the memory chips fail at 2 volts and the memory controller fails at, like, 2.5. That doesn't mean it couldn't have degraded the memory controller, but, you know, like, I'd rather have a card that outputs an image than a card that doesn't run at all. So, yeah, like, so I'm kind of hoping that, you know, maybe, just maybe, the memory chips acted as, like, a sacrificial energy sink for the VRM failing, because I don't know what that VRM did when it failed, right? Like, the CHL8228G is, like, it was completely toast, so was it holding the memory power rail on? Was it leaking 3.3 volts into the memory, like, output? Because it was leaking, you know, memory voltage was leaking into like, when I was injecting voltage into the board, it was leaking voltage into 3.3 volts. So logically, 3.3 volts could have easily been leaking into the memory system, into the memory power rail. Man, could you... I think I cleaned these memory chips a bit too well. Oh, that's a 0.7 again. All right. Doesn't help that my probes aren't particularly sharp. That's another 0.7. That one's toast. So I really think every single one of them died. So at least now I don't have to feel like a complete idiot, because I jumped the gun with removing the memory chips. I should have, like, the one lesson I've learned from this card is remove everything before you start removing BGA. I mean, ultimately I probably would have had to remove all the memory chips. Yeah, 1 ohm. That's you know, that's less dead than the other ones. I guess this was located, like, far away from the memory VRM. But yeah, that one, like, that's still dead. I wish I had a healthy memory chip for comparison here, but that's not really a thing I have on, like Like, I'd need to pull one from a GPU, and that's not really a thing I have on hand. Super dead. Yeah. Okay. Well, at least I don't, like, the thing is, I would suspect that healthy memory chips have a resistance of, like, I don't know, hundreds of ohms, if not thousands of ohms, because you have to consider, there's 12 of these things. Right? There's 12 of these things on the card, and all of them put together in parallel, along with the resistance of the memory controller, combined to somewhere around 30, 40 ohms. So, like, you need to be able to take the resistance of one memory chip and divide it by 12 and get, like, something close to the final resistance of the whole of the memory as it's installed on the actual GPU. So the memory chips registering 1 ohm each is just kind of like, yep, super dead. Anyway, let's check this one. Failing at it again? Oh, that one's less dead than the others, but 1.2 ohms is not a working memory chip in my book. And what about you? Very dead also. 0.9. Yeah, I think all, like, it makes sense. Like, they were all getting really hot. Now, some of them were getting hotter than the others, but we can already see that from the resistance measurements, right? Like, some of these are registering, oh my god, this one's super dead. This one's 0.5. Yeah, so like when I was injecting voltage into the card, a chip like this one, which has half a ohm of resistance, right? This one's going to be sucking up at 1 volt. This thing's going to be sucking up like 2 amps, right? Whereas some of the other chips would only be sucking up 1 amp, right? Because the other chips, like there's a few chips that are like 1 ohm of resistance, so at 1 volt they'll pull an amp. But this one will pull like 2 amps, which would explain why some of the memory chips were significantly hotter than the others. Because some of them are significantly more shorted out than the others, but that doesn't change the fact they're all still dead. Okay, let's get this last memory chip checked. And... yep, dead. Okay, cool. At least I don't have to feel like a complete idiot. Right, like one way or another, I would have had to remove every single one of the memory chips anyway, because they're toast. Unless like the removal unless I cooked them in the removal process. But I really doubt that, because like it makes sense that they'd all be shorted, because the card came with a really, really low resistance on the memory power rail. So yeah, that's rather unfortunate. I was really hoping for an easy fix, like dead low side. Like, I was hoping for dead MOSFET, okay? Like, because here's the thing, with the 7970, worst case scenario, dead MOSFET, I would have to, like, E-power the card. Whereas dead memory chips is like, well, you gotta replace the memory chips. And that's just, like, that's never, it's not, you know, not my idea of a good time. So, yeah. Anyway, at least I don't have to feel like a complete moron for removing the memory chips before removing the CHLA228, because, like, the correct way would have been remove the CHLA228, then check if the memory chips are still shorted, and then desolder the memory chips anyway, because they would be still shorted, right? Like, yeah. But that's it. So, yeah. I guess, you know, if you have a 7970, or one of these cards using an CHLA22, or I guess any card, right? Like, I don't think the, like, internal short circuit failure of the CHLA22A, I would assume that's not, like, a fundamental design flaw of this specific voltage controller. It might just be, like, a somewhat generic failure mode for voltage controllers on very, very old cards, right? 7970s are certainly not modern by any means. So if you have a, you know, a 7970 or a 7950 or even like a 7870, 7850, because those use a CHL 8225, which is basically a dumber, like a weaker version of the CHL 8228. Well, a lower phase count version of the 8228. There's also some 7870s that actually use an 8228. I think 280X's still use A228s. Like, there's a bunch of cards that use the CHL A228 and A225. So basically, if you have one of those cards with one of these chips, or any other chip, and you have a short circuit that just doesn't make any sense, like you can't find it, might be the voltage controller. Though I guess if you didn't have all the memory chips shorted out, the voltage controller would actually get hot, right? Because that was the main issue, is like when I tried injecting voltage into the card, The problem I was running into was like the memory chips were all getting insanely hot, and the rest of the card by comparison was relatively cool. But also, what helped figure out that it was actually the controller was one, somebody suggesting it on Discord, but also when I left the card just sitting on my desk with the RX 480 VRM hooked up to it for, I don't know, like 20, 30 minutes, the whole card cooled down except for the like voltage controller. Which initially I thought that was just because I was injecting the voltage, but nah, it was the dead voltage controller. So yeah. Anyway, if you have a, GPU with a weird short circuit that you can't hunt down, it might be the voltage controller. That doesn't mean it can't still be all the memory chips, and I've also had cards in the past where the actual chip itself was shorted out without having any visible damage, like I had a 980 Ti where there was a really low resistance short circuit on the V-core rail, and it didn't go away until I desoldered the like actual GPU core. So yeah, that's also a possibility. So, but most of the time you would hope that like if you have a normal short circuit, you usually hope for it being one of the MOSFETs, not this. This has to be this is the first time I've seen anything like this. But yeah, first time, yeah. I don't think I've seen anything like this before, where like all of the memory chips are dead and the voltage controller's dead. But hey, at least I still got my hands on one of these very rare 7970s. Now, if only I had a working one. And my 7970 collection is almost complete. Almost. Yeah, anyway, that's it for the video. So hopefully this was somewhat interesting and helpful. I will be doing a PCB breakdown of this card eventually. And when I say eventually, it could be in a year. I really don't know. Like, we'll see. I hope not. Like, yeah. Though there are like motherboards that I was like, oh, I'm going to do a PCB breakdown. And then a year later, I have a script written up, but no PCB breakdown. I should really end the video. So yeah, thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, hoodies, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel. Mostly in, when it comes to acquiring things like this 7970 right here. And so it would be much appreciated if you'd check them out. Yeah, that's it for the video. So thank you for watching, and goodbye.